Hello everybody and welcome back. Today I'm going to teach you how to do a scan mechanic in Unreal Engine 4. So as you saw in the final result, this is it once again. When I'm going to press my button, some objects are going to get highlighted in a red color. And as well, you could see this kinda scanner that is going on the ground. So that's what I'm going to teach you today, and without further ado, let's start. So this is the material that is going to be on the ground, so the scanner. This is going to be the highlight material, this is going to be the character blueprint, and this is going to be a material collection parameter, or whatever it's called. So this is going to help us set the radius. So first let's begin with the scan material. What you want to do first is to get a sphere mask. So this sphere mask is basically going to set so the material is going to basically be a circle that is going to have its center masked, as you can see, and you can only see the outline. Okay, so what we want to do here is to get the absolute world position and then get the camera position. So this way we know where the center of the circle is. Here we want to get a radius and here a hardness, but here we want to do something special. We want to go here in the content browser, right click, go to materials and textures and create the material parameter collection. Then go in there and create a new scalar parameter. So this way we can set the radius, as I said, name it radius and give the default value to be 0. Alright, then what we need to do here is to get a constant called hardness, and you can either make it 0.5 by default, or you can set it as a parameter and then do something in an instance, as I did here. So as you can see, I set the color and the hardness in an instance. Okay, then what I need to do is to get an if. So this is going to compare two values, and out of the sphere mask that should be A, and then a constant 0.9 should be B. And if A is greater than B, then this should be 1, a constant should be 1, and then if A is less than B, the constant should be 0. So this way we can set the actual alpha of a linear interpolation right here that we'll have, because the alpha takes values from 1 to 0. Okay, then here what you need to do is to set the actual outline color, and again, as I said, you need to get a constant shift vector, and you can either set the default value, or you can make it a parameter and then edit that into an instance. Then what you need to do is to get the post-process input 0 and mask that with an RGB. Okay, then what we need to do here is to get another linear interpolation and plug that into the emissive color. So we're going to end with that and make sure you have here the material domain post-process. Okay, and now let's see what about B and alpha. So again, into the B we should have a post-process input 0 and mask the RGB and plug that into B. And a post-process input 0 is basically a scene texture, and here are the scene texture ID. You need to go here and post-process input 0. And again, the alpha here is not going to be the if one, is going to be the actual sphere mask. And that's it for the scan material. And then if you're going to create an instance, you just go here and edit these values. So as I said, the hardness should be 0.5. That works great for the scanner. Then here we have the outline. Actually the highlight, not an outline. So what I had here is a scene texture which had custom depth, and that is right above the post-process input 0. Then we had to mask the R, add the masked R with a constant that is pretty big, just make it as big as it gives an error right here. Add these values up, then divide them, so the constant to the add node, then multiply that with 2, and that is because if this would be 1, I think nothing is going to, there's going to be no effect, as you can see. So that's why we need to multiply that with 2. Then we need to floor. So floor is going to, so let's say we have here a constant 0.23. The floor is going to set it to be 0, and if we had let's say 1.73, then this would be equal to 2. Okay, then what we need to do is to clamp this value with 0 and 1. So if this is going to be less than 0, it is going to be automatically transformed into a 0, and this would be, let's say, 2.73. This would go back to 1. Then we need to multiply again the floor with a constant 0.5. This is going to be the alpha of the color. So if this would be 1, I think the color would be stronger on the object. As you can see, it's going to be straight red, but when I'm going to put it 0.5, it is going to be a little darker, as you can see. Okay, then we need to multiply these values up. Again, we need to clamp them, and that is going to be our alpha. The reason why we are clamping this here, because alpha, again, gets values from 0 to 1. Then here we're going to get the scene texture post-process input 0, mask the RGB. Here we are going to get a vector t constant, which you can again set into a parameter and then edit that into an instance. And here into the material, go to material domain, set post-process, and plug this linear interpolation into the emissive color. Apply, and that's it. Okay, so we don't need this, and neither the scan material. So this is all for the material part. Now we are going to need to go into the blueprint. So let's just comment this right here so we know what you're going to have. So here I have an input action mapping called use binded to my button. So in order to get one of those, go to edit, project settings, let it load. Alright, go to input, make sure you're on action mappings and not on axis mappings. Click on this plus, give it a name, give it a button, and that's it. Okay, didn't mean to do that. And then we have here a do once. One thing that you could do here is that you could use branches, but because I was lazy, I did it with a do once. Okay, so out of completed, what we want to do is that we want to do two things. We want to do two timelines, which are going to, one, update the scalar parameter that we created, so the radius of the actual sphere. So this is why the circle is going to have a bigger radius. And then we want here to have a sphere that is going to have the sphere radius 0.1, and then again update that with a timeline, the exact timeline as the first one. And actually I think you could just set the sphere radius to be 0. Alright, so here just make the timeline. Mine is like this: time 0 value 0, time 5 value 50,000, and the length of 5 seconds. The second one is the same, and on updated we want to set the scalar parameter value, set the collection here to be radius and the parameter name to be radius, plug the new track into the parameter value, then just copy it, and instead of the parameter value to be the new track 0, make it to be 0, so it is going to get resetted. Then here we are going to need to have a set sphere radius out of the sphere, plug the new track 0 into the sphere radius, and here once it's finished we want to reset it to be 0. And make sure you have here update overlaps so we can do something else. So this is a something else. We are going to update the set custom render depth based on objects that have some tags and all that stuff. So let me begin. Here I have an uncomponent begin overlap of the sphere, and I'm checking if actors have tag. And if I'm going to go into these three cylinders right here, and I'm going to search for tag, you're going to see here actor tags 0 and scan. And if I'm going to go here, actor has tag, tag scan, and I'm going to check if it has or not the tag. If it is going to have, we are going to set the render custom depth to be true, and on event and overlap, then we are going to have here actor has tag scan, and if that is true, we want to set the custom render depth to be false. And one more thing that I forgot, and it is really important, what you want to do here, you need to have a post process, and you need to go into the material. And here, you need to create in the rendering features, post process material and array, create two elements, and one of them should be the scan material, and one of them should be the highlight. And that is pretty much all for this tutorial. I hope, as always, that you liked and enjoyed this video, and as well, I hope that you'll learn something from this tutorial, and if you did, don't forget to subscribe to my channel. And guys, until next time, goodbye.